Welcome back, Algebra Express. We are in Marecek 6.3 and 6.4. We're doing a factoring strategy, including difference of squares with this title. Okay, so the last two sections, we learned how to group and factor four terms. And the previous section, we learned how to use the AC method on three terms. And if I'm being honest, the difference of squares, you can actually do it with the AC method, but it's something that you're going to see time and time again, and it's easier to just sort of take this sort of shortcut that they're about to show us. And so I want to start, not with what they have here, but I think it's like x plus 5, x minus 5. We did this when we did distribution. We called this thing a conjugate. X squared. If I write it in this order, it is x squared minus 5x plus 5x, and then I have minus 5 is the last thing. And so when we did conjugates, we noticed like this middle term simplifies to 0x. So what we actually have is something that looks like x. So that is conjugates that's going this way. Now we want to think about it going the other way and what that sort of looks like. So you might notice both of these terms are squares and there's a subtraction sign in the middle. So that's where we get the name difference of squares from. And that's all they're saying, like right here. If we have two conjugates, we multiply them together, we're going to get to the difference of their squares. It's going to be the square of the first term minus the square of the second term. Now we're going the other way. We're going to factor these things. So we're starting with the square. So the first thing I'm thinking is I see an x squared here. And that's like my A like my x squared, or my A like my x squared. My b squared. And so I know my a squared and I know my b squared. But what I really want to know is like my a and b. And so to get from a square to a single term, root of x squared would be x. And we're looking at x and 4. So if we're looking at x squared minus 16, what we're thinking is square root this thing, it is x. Square root this thing, it is. I have two factors. One of them is going to be plus. One of them is going to be minus. Okay. So now we're looking at this thing. And for it to be a difference of squares, they both have to be squares and there has to be a subtraction sign. That's the form of the formula. So we're looking at this thing. You might notice 5y cubed, like probably the first thing you notice is like that is not a square. Okay. And I said it last time. It's probably going to be the thing that you forget. But the first thing you should do when you try factoring something is take out a GCF from everything. So we're looking at this. And if we do take out a GCF, we can take out a 5. If I take out a 5, why is it squared? There. Okay. And now I'm looking here. Where's my other color? There we go. I'm looking at just the y squared minus 16. I want to factor that. And so how do I factor something like that? I'm not spending too much time, but it's just like this. Let's look at like y minus 4. And then don't forget GCF down. Okay, so we had something like x squared minus 16. And so if we want to write this with three terms, we have an x squared term. We have a minus 16, which looks like a constant. So the term we don't have is a x term. So if we wanted to write it, it's a coefficient of 0. It's still not going to appear there. So it's still not making a difference. But now I have this thing in standard form. So this is, I can do the AC method on this thing. But I want something that multiplies to AC. Minus 16. And it's going to add to B, which is 0. And so if we do this, we have and 4 and 4 are our factors. And for it to multiply to a minus 16, one of them has to be negative. So the thing that does it is a negative 4 and a positive 4. Okay. So the next thing they look at down here, they look at x squared plus 16 is what they're doing. But what about x squared plus 16? That's what they're asking now. Because we just did x squared minus 16 was what this was. We just wrote it with a dummy 0 in the middle. So the same thing with this, x squared plus 16. If we want to try doing it with the AC method, we can let x squared plus x plus 16. And now we're asking ourselves, can we find something that multiplies to a times c, which is 1 times 16? So now we're looking for a positive 16. So previously, this was a negative 16. Now we're looking for a positive 16 next to 0. It's still the same factors, 1 is 4 and 4. And if it's positive, it goes positive, and now we're going to write them all out. Get this all on there all at once. There we go. Now I'm going to write them all out because any of those that you add, you can look all along there, 17, 10, or 8. So there's no way to make these opposite signs and add to 0 like we did previously, basically, right? Because in order for them to be opposite signs, the sign on this thing would have to be different. So we're kind of stuck if we make this positive, that we're not going to be able to find factors that are going to add to 0. And so we look back at this. What about things like x squared plus 16? Or you can either way, that's the same thing. We're not able to factor them at this point. So we're just going to call these things prime. Ooh, now we're going to factor a to the 4th minus 81. Well, this gets tricky. Is this the difference of squares? We're looking at this thing. It looks like a to the 4th. If we think about a to the 4th, we have how to make square roots of these. But if you take a square root, it is kind of like, how do I say, you're dividing by 2. Trying to beat around the bush too much, I think. But if you think about a squared, squared, 4th. So a to the 4th is like a squared being squared. And we went over exponent laws or exponent rules. So there they are, coming in back into play. But if we square a square, we're going to get to a 4th. And so with that said, if we look at a to the 4th minus 81, if we take a square root of a to the 4th, that's going to be a squared. 81 is going to give me 9. So I have an a And it's a difference of squares, so one of them is plus, and one of them is minus. Okay. And it says to factor this. Now we're getting to the point of where I'm going to ask, is this fully factored? And so if we look here, this is an a squared plus 9. This is the sum of squares like we tried to do up here. Couldn't do it. That was the thing that was prime. This thing is still, that's a square, and that is a square. So that is a difference of squares. A squared plus 9. I can't do anything with that. I'm just going to bring it down. But this thing, I can still factor this thing into the square root of a squared. Square root of 9 is 3. One of them is minus. And so that's taking place of that thing. So they can hide a difference of the squares and a difference of the squares is what they can kind of do. We can hide a difference of squares in larger things as well. So okay, so now this is student activity. Hopefully you're working your way through this on your own. Now, what do they say? First step is to order and find the GCF. Take out a common GCF if there's a common GCF. Classify by number of terms. Final steps, factor completely in check. Okay. Before starting, make sure the terms are written in order of. Okay, so they're asking about the powers or the exponents. So if you're writing something, you want to write something, and I've said it before, descending order. The first step in every factoring problem is you always look for a right there in their instructions. We just read the first step. You always find a GCF if you can find a GCF. Okay. Two-term polynomials. So they give us a few two-term polynomials. Which polynomial above is not possible to factor? Circle it and briefly explain how you know and the blank below. So which one of these can we not factor? So hopefully we just went over this. So hopefully the one you're looking at is that one right there, the 4x squared plus. Can we not factor that? That was the thing that we called a sum. So that's if you have a square here and a square here, and there's an addition sign between them. We cannot factor it. We just call them prime, and we're done. The difference of squares, which of the polynomial above is the difference of squares? That would be the 25x squared minus 9. And so maybe this one is a little bit different because we have a coefficient on our first term, but it is still the same. Square root of 25x squared. I'm taking the square root of 25. That's going to give me 5. I take the square root of x. It gives me x. This is what you need. You want to take the square root of it. So I have a 5x and a 3 plus. One of them is minus. Okay, and then the last thing, GCF. So it's the only thing we haven't done there yet. So 16 minus 8z. And really the first thing you should do, like I said, is rewrite this thing in decent. Minus 8z plus 16. Between 8 and 16, we can take out an 8, and since it leads to the negative, take out a negative. Minus 8, this is going to be z. And now this becomes minus 2. Okay. And is that fully factored? One of the indicators is that you're down to your first power of your variable. So if you have nothing but first powers of your variable, that's a pretty good indicator that you're done. There's no way to simplify this and boil this variable down further, right? Same thing here. We're single powers. There we're at a second power, but it's prime already, so we can't do anything with it. So that is fully factored as much as we can. Okay. 3-term polynomials. Okay, so they're going up. They're going from 2 terms to 3 terms. And then we're going to talk about 4 terms. So, what method do you use to factor 3-term polynomials? And we did this last time. The AC method. So the AC method basically is you take that middle B term and you split it up into 2 terms. And ta-da, you have 4 terms. You got to make a 3-term, 4 terms. Okay. What method do you use to factor polynomials with 4 terms? So this was the thing that we could use 2 different ways. The first way that they talk about is factor by grouping. It takes place in the factor by grouping would be the box method. So either way you want to do this. If the box method helps you keep things straight, you can do that. But it's just the same thing as doing factor by grouping. Factor completely in check. The following polynomials are not factored completely. Identify which factor can be factored further and write a complete factorization in the blank provided. So this thing, sometimes if you don't take out your GCF, you might end up with something that looks a little like this. And so what you end up with is something x plus 5. I hope you notice x plus 5 is fully factored. There's nothing more we can do with x plus 5. It's the first power of x. This one, however, has 2 x's. This one has 1 x. So out of this first term, I can factor out an x. Factor out an x from this. That's going to drop down. This is power of x. It's going to drop down that power of x to just a minus 1. And then I still have that x plus 5 tagging along. Okay. So sometimes if you don't pull out your GCF, one of these things will look a little fat, like it's got a little extra thing there, and you got to pull it out at the end. So. Or it won't be fully factored and you won't get to all your points, right? But I want you to get it all the way. Let's do it. X squared minus 25, and then we have 2x plus 1. If I do x squared minus 25, well, let's look at this one. 2x plus 1, I hope you realize that one is fully factored. It is the first power of x. There's nothing more we can really do to break that down. This thing looks like x squared minus 25. This is the thing we were talking about previously. So this is the thing that looks like square root and square root. So I have x and a 5 and an x and a 5. A1 plus and A1 minus, and then the guy tagged along with 2x plus 1 is still there. And how would we check our factoring to make sure that it is correct? Well, let's look at something that we actually factored all the way. That might be the easiest thing. So if we factored something, we have this factored form of x plus 4, x minus 4. How will we make sure that's x squared minus 16? And the way that you check your factoring is if you go this way, it's factoring. And if you go that way, it's distribution, right? And so if you want to check factoring, the way to do it is you do distribution. This would look like x squared. And that's kind of how I started off, right? You know distribution better. And so when you want to check something, go with the plus 4x minus. And we can factor that, and we can figure out this middle term is going to simplify away. I don't want to write a whole bunch of stuff here. But the way that you check distribution, or sorry, the way that you check factoring is distribution, right? So those will simplify. And it's going to give us back to the original polynomial that we had. So how do you check to make sure your factoring is correct? You do distribution. And that's true whether we have a difference of squares, whether we have a trinomial that we started with, whether we have a 4-term polynomial. If you want to check your factoring, you can do distribution. And it says caution, it doesn't the process doesn't check to make sure it is fully factored. So this only makes sure you factored it correctly. It doesn't make sure you factored it all the way correctly. That's what they're saying. Okay. So now we have some student practice. And so what you should think about each of these is how many terms do they have? So the terms is going to tell you your factoring strategy. But even before our terms, even before we start doing all that, what we want to look for, the first thing you should do, always, is look for a GCF. If we look for a GCF, I'm looking here 2, 6, 8, and 24. I think I can take out from each of these. X cubed, x squared, that's 4x. So I'm dividing everything by 2. The next thing, I ask myself, how many terms do I have? This 2 is just out here kind of by itself. It's our GCF. Looking at this thing, how many terms do I have? 1, 2, 3, 4. How do I do 4 terms? Factor by grouping or doing the box method. So I'm going to do this factor by grouping. I do x squared. That's going to leave me with a x plus. If I do a minus 4, then it's x. So what it looks like I'm getting out of this thing is an x plus 3 and an x squared minus 4. And if you got this far, you're doing pretty good. But don't forget, remember, the first thing you should remember is your GCF, and then the second thing you should remember is to always bring that guy down. Whew. So there's 2 things they're trying to get you with, right? You might forget that GCF, take him out at the beginning. You might forget to bring him down. Now we're looking at this thing. If we want to check the factor, we can check the factor, but that doesn't tell us if it's fully factored. Is this thing fully factored? So this thing is factored, this thing is fully factored. If I'm looking at this, this is an x squared minus 4. So this is still a difference of squares. So for this, I'll break this up. Do square root, square root, square root, square root. It should look like x plus 2, x minus 2. We have a single power, single power, single power. And if you didn't take out this 2 at the beginning, like I said, sometimes you might have something that looks like 2x plus 6 or something like that. And so maybe if you had something like this, you might recognize there's an extra 2 that I could take out of this one. There's going to be a factor that looks a little extra, right? It's got a little more than it should. This is not what we want. We want to go. So take it all the way. Another thing to maybe notice is we have 1, 2, 3 of these factors, right? This is like a coefficient. There's no x's on there. What I'm talking about is like factors with x's, right? I have 1, 2, 3 of these sorts of factors. And if I look at the original equation, I started with a third power of x. So in general, those things should match, right? The powers on my x's in the beginning and in the end. So that's a good sort of check to also do. Make sure you're not way off. Okay, so now we're looking at this thing. It looks like kind of a nightmare maybe. But with a little adjustment, I think it might look a little prettier too, factor. If we look at this thing, the first thing you should always look for, and if you don't in this one, you're going to have a heck of a time, you should look for your GCF. The GCF of this thing, 12, 144 is going to be 12 squared. So that and take a 12, I'm probably also going to want to take a negative out of that thing. The lowest power of t that I can take out squared. If I take out a t squared, I'm taking out 2 of these t's and leaving t squared. Minus 12 plus 1. I'm taking out 2 of these t's and leaving the t. This is 144 divided by a minus 12 is a minus 12. I'm taking out my t squared. I have no more. All right, took out my GCF. Okay. Is this fully factored? Okay, so I guess here's the thing. We could write this as minus 12t times t if you really wanted. It's okay to combine like these single t's into a t squared. That's fine. So this I would say is fully factored already. The thing we really want to work on is like this thing over here. That thing is not fully factored. If I'm looking at this, I'm thinking, how do I factor this? And so the first thing I do is count the terms 1, 2, 3. How do we factor 3-term things? We have to do the AC method. So if I do the good old AC method, A times C minus 12 is a minus 12. It's going to add to I'm looking at 1 and 12. 4. And it's going to add to positive 1. In order to multiply to negative 12, one of them has to be positive, one of them has to be negative. So where do I want to put my negative so that they add to positive 1? And I'm going to put it right there. Okay. So there are a few different ways to do this. If you do the box method, if you split that middle term apart and factor by grouping, that's good. But I want to save a little bit of time. And what I want to do is I want to look at this. And it has a 1 coefficient in the A spot. So if I factor this, and if you do the box method or factor by grouping, you should get the same thing. Plus 4. So that's what that thing's going to factor to. It's going to factor straight to these magic numbers. I'm going to write the whole thing minus 12t squared, and I'm bringing this down to minus 3t plus 4. And that's what this thing should be. And that's fully factored. Okay. Now we're doing 11A. So I'm looking at this thing. The first thing you should always look at is, do I have a GCF here, a greatest common factor? Between 4 and 5 and 6, I don't think you're going to pull out anything. And this one doesn't have any A's, so I don't think you're going to get any A's out of there. So now I'm looking at this thing. I have 3 terms. I'm thinking, how do I factor 3 terms? How do I factor 3 terms? I got the AC method to do. Times C. 6 times minus 4 minus 20, which is 5. 24 is 1 and 24. 2 and 3 and 8. 4 and 6. And if it's a minus 24, they multiply 2 and they add to 5. I believe I have to put a negative on the 3. You might be tempted, after I just did that one, to say something like A minus 3A plus 8. Oh man, don't do that. Does not work here, right? And it doesn't work here. And you remember, again, because my A, that's a horrible, that's a horrible variable to let that be. But my A term is 6 right here, right? The 6 right here is not a 1. So I cannot use my shortcut. I realized how that was going to sound verbally after I thought about what to say. So what I want to do is split the middle term apart into minus 3 and 8. I got 6a squared. I want to go minus 3a plus 8a minus 4. And again, if you want to do factor by grouping, or you want to put this in the box, either way should work. I think I'll go with the box on this one. A squared minus 3a plus 8a minus 4. Between 6 and 8, I can take out 2. A squared and 1, I can take out an a. Between this one and this one, I can take out a minus 1. Between 6 and 3, I can take out 3. 4, I can take out 4. Ooh, and I forgot my a here, and a plus here. So this thing should factor to 2a minus 1, 3a plus 4. Okay, so now I'm looking at this fully factored. Is there any GC up in here? Is there any GC up in here? Are these all first powers? If so, I think we're pretty good. This should be fully factored. Now I've been pretty lazy about this section, and they like specifically told me to do it. But what I should do what I should really do is, this is my solution. If I got enough time and I want to make sure I get all my points on my test, convince me what you learned. Minus 3 minus 4. And you might have yourself familiar. We should arrive back at our original equation if we do some distribution. Okay. Now we're looking at 16p to the 4th minus 1. So we're looking at this. Is there anything in common I can take out? If I look at 1 and 16, there's obviously no common factor between 1 and any other number, right? So we get down to 1, it's going to be just 1. I look at 2 terms. I have one way to factor 2 terms, and that way is called a difference of squares. So if I want to do difference of squares on this thing, I want to take a square root of 16, which is 4. I want to take a square root of p to the 4th. And we talked about this earlier, but square rooting, it's kind of like you're dividing this thing by 2. Because if we square something, we get back up to it. And it's like multiplying by 2. Raising exponents to a square would multiply things by 2. To get the other way, we divide by 2. Is probably the best way to say that, right? So that's a lot of talking to say that is 4p squared. Oh man. And this is a stupid thing, but square root of 1, 1 times 1 is 1. And for a square root, we wanted to be able to take things out in groups of 2. So square root of 1 is 1. 1 squared is 1, right? So square root of 1 is 1. So don't let the 1 maybe confuse you. But this is 4p squared minus 1 looks like 4p squared. And I have a 1. And one of them is minus. And I have a 4p squared plus 1. Okay. And these are conjugates. I can multiply them together. Check to make sure I get back up there. And it should work. The middle term should simplify out. But now I'm going to ask the question, am I fully factored? So if we're looking at this thing is a sum. So the second we see it's a sum, I can kind of stop there. The only thing I have for 2 terms is difference of squares. So it's not going to be a difference of squares. That is going to be prime. The other thing, I'm looking at this here. This is 2 terms. It's subtraction. Are these things both squares? 1 is a square, 4 is a square, and p squared is a square. So this thing I can still break down. So I want to take the square root of 4 is 2, square root of p squared is p. Square root of 1 is still 1. So I have a 2p minus 1, I have a 2p plus 1. And I have a 4p squared plus 1. So sometimes we still got to break these things down multiple steps. You have to factor, and then you have to factor some more. And then after that, we're going to have more factor. But here's the good thing. The more you do it, the better you become. So get a little bit of work on these things, and they will go a lot smoother, and the rest of the semester will go a lot smoother. Just put in a little bit of work each day, and things will get easier. 2x to the 3rd minus 7x squared plus 3x. So we're looking across this thing. 2, 7, and 3. First thing I want to take, and that's what I was going for, is I want to take the GCF of this thing. So I was thinking 2, 7, and 3, yeah, ain't nothing there. I can take a GCF of. the next thing I look at is my variable. So I can take an x out of everything here. So if I take an x out of everything, everything is going to drop by the power of x. I'm going to have 2x squared minus 7x plus 3. Now looking at this, this is a little GCF out here. I want to concentrate on that thing right there. I think, how do I factor this? This thing has 3 terms. I want to do the AC method. So A times C is going to give me 2 times 3 is going to give me 6. I'm looking for things that multiply to positive 6 and add to minus 7. 1 and 6, I guess I could do more factors, but I think it's going to give me it right there. 1 and 6, they're not going to add to minus 7, but if they're both negative, they will. So I believe it's minus 1 and minus 6 that I need to break this middle term up into. So 2x squared minus 1x minus 6x plus 3. So I'm going to factor my grouping these, I think. So out of the first two, I can pull out an x between 2 and 1, there ain't nothing, but I can pull out an x between these two. So this is 2x minus 1 between 6 and 3. It leaves us a negative, start with a negative, negative 3, and then I'm going to have 2x minus 1. And this thing factors to 2x minus 1, x minus 3. And if you put this, and you multiply things together, you might notice we started out with a cubic term, and we're only getting 2 x's. Oh no, what happened? Don't forget to bring down your GCF, right? We had that GCF of x we took out in the beginning. Now we're looking at this thing. Is that thing fully factored? It should be. I don't know how much else you're going to do. So, what am I? 75 into the third minus 3n. Oh. So, is this the difference of squares? Not yet. And what we're going to have to do is look for the first thing. Always first thing is look for a GCF. So the GCF here, I believe, is, I say that 3n divided by 3, so you use 25. 3n minus 1 is going to be 3 minus 1. So I have 25n squared minus 1. When I factor out a 3n, what I want to do now, I'm looking at this thing. 3 into the first, that's my GCF that I took out. Those things are done. Once you factor out your GCF, we don't have to worry about factoring them anymore. 25n squared minus 1. This is 2 terms. Difference of squares is hopefully the first thing that pops into your brain. If I got 2 terms, is it a difference of squares? This is a difference of squares. Square root of 25 is 5. Square root of n squared is n. Square root of 1 is 1. So it looks like 5n and 1. 1 of them is plus. 1 of them is minus. And don't forget that. Bring that 3 in. If not, when you go back to check this, things aren't going to check. So hopefully you check, you make sure you have all your powers. 1, 2, 3. We started out with n to the third. Okay, and that's the last problem we have for today. I will see you soon, and we will have some factoring review and go over factoring a few more times. See you soon.